Friends, in the previous classes we have learnt about the physical properties of bases. Now about the chemical properties of bases. What are the chemical properties of bases? That means what happens when a base reacts with other substances. Somewhat is formed. That means some more new substances are formed. If other new substances are formed, then that is called as chemical reactions. First, reaction of bases with metals. Already we have learnt about metals. Simply, what are metals? The elements which are electropositive in nature, that are called as metals. Examples are zinc, copper, magnesium, potassium. All these are called as metals. We know when acids reacts with metals, that what are that acids? When acids reacts with metals, what are formed? Respective salt is formed and hydrogen gas is released. That means most of the metals reacts with acids and forms corresponding salt and hydrogen. Then what about the reaction of bases with metals? Only a few metals reacts with bases. Not all the metals reacts with bases like acids. In the case of acids, most of the metals reacts with acids. But in this case, that means in the case of bases, only a few metals like zinc reacts with bases and forms corresponding salt, and again hydrogen gas is liberated. Let us observe the reaction of base sodium hydroxide with a metal. What is that? Zinc. Say zinc, and what is formed. To observe that reaction, set up the apparatus as shown in the figure. How do we set? Simply first take a boiling tube. In that boiling tube, few zinc granules or zinc pieces are taken. Add sodium hydroxide solution. That means sodium hydroxide is a base. Actually, in our lab, the sodium hydroxide is in the form of pellets. Okay. Is the sodium hydroxide or the sodium hydroxide pellets are added to zinc, then is the reaction takes place? No. First prepare aqueous solution of sodium hydroxide. How do you prepare that aqueous solution of sodium hydroxide? Just take required amount of water and add the sodium hydroxide pellets in required proportion. Stir well with a glass rod. Then in the beaker, aqueous solution of sodium hydroxide is prepared. This aqueous solution of sodium hydroxide is added to the zinc pieces which are taken in the boiling tube and fix it to the retort stand as shown in the figure. Whenever we fix, immediately cover the mouth of the boiling tube with a single hole rubber cork, and a delivery tube is passed through the hole. Other end of the delivery tube is placed in a jar which contains soap water. Then within a few seconds or few minutes, we observe formation of bubbles near the zinc granules. Formation of bubbles near zinc granules means, near zinc pieces means, these two substances are reacted with each other. What are the two substances? Sodium hydroxide, aqueous solution of sodium hydroxide, and zinc. These two are reacted. Whenever the reaction starts, then automatically we observe gas filling bubbles are formed in the soap solution and they rise up into the air. Okay, that means this formation of gas filling bubbles shows that a gaseous substance is produced or liberated during this reaction. What is that gas? Test that gas. How do you test that gas? Take a burning splinter. Place the burning splinter near the gas filled bubble. Simply the splinter is put off and the gas burns with blue flame. That means which gas it is? Hydrogen gas. That means where sodium hydroxide is a base, reacts with zinc, which is a metal, then a salt. What is that salt? Sodium zincate, which its chemical formula is Na2ZnO2. Sodium zincate is formed and hydrogen gas is liberated. How the hydrogen gas is produced when an acid reacts with metal? In the same manner, when a base reacts with metal, corresponding salt is formed and hydrogen gas is liberated. But students, observe one thing, keep it in your mind. This must be keep it in your mind. Acids reacts with most of the metals, but bases reacts with only a few metals. Here sodium hydroxide reacts with zinc, corresponding salt, so sodium zincate and hydrogen are formed. How the sodium zincate is formed? Simply this sodium hydroxide splits into Na plus and OH minus ions. Okay, and this in this formed salt, ZnO2, that is negative part, and Na2, it is positive part. This positively charged part and negatively charged part, negatively charged part anions, positively charged part cations. These cations and anions are combined and formed a salt, what we call as ionic substance. Like that, corresponding salt and hydrogen gas is liberated. Okay, then how the acids, bases, sorry, not acids, bases reacts with acids. Generally, what happens when an acid reacts with a base? We know base is the substance which neutralizes acid, or vice versa. That means acid is a substance which neutralizes base. That means if the basic nature of a substance increases, then what we need to neutralize that opposite to base. What is opposite to base? What is the substance which is opposite to base? That is acid. Okay, that means when an acid is added to base that are reacted with each other, that means the two are neutralized with each other, corresponding salt and water are formed. That reaction is called as neutralization reaction. Okay, how the acids reacts with bases? In the same manner, bases also reacts with acids. That means when a base reacts with an acid, then what are formed? Corresponding salt and water are formed. It is the best example for neutralization reaction. Why? Acids and bases are the substances which their nature are opposite to each other. Already I told you, if an ant or honeybee bite us, we observe severe pain. That severe pain is due to that ant bite, an acid is injected, that is formic acid or ascorbic acid. When that formic acid or ascorbic acid is injected at that region, that means at that area, we observe severe pain. Then what we have to do? We have to neutralize the acidic nature. To neutralize that acidic nature, we have to apply a base near the stung region. Okay, where the bite is given, at that region we have to apply base. Then automatically this base neutralizes the acid. Then there is a relief. That means these two are neutralized. Let us observe the reaction of sodium hydroxide with sulfuric acid. Sodium hydroxide solution is taken. Okay, but observe one thing, these are not in pure concentrated form. Aqueous solutions of acid and aqueous solution of bases, these are only reacted. Why? Acid produce H plus ions in the presence of water, and in the same manner bases produce OH minus ions in the presence of water only. That's why they splits into its respective ions in the presence of water molecules. That's why to observe this neutralization reaction, we have to take this acid and base in its aqueous forms only. Okay, an aqueous solution of sodium hydroxide is taken, aqueous solution of sulfuric acid. Then what is formed? A salt, sodium sulfate is formed and water is liberated. Actually, how it is happened? This base splits into NaOH base into Na plus ions and OH minus ions. Already we know base produces OH minus ions. And metal part, that means positively charged part is there, that is Na plus. And acid, it splits into H plus ions and SO4 minus ion, that means negatively charged part and H plus ions. What negatively charged part means? That is non-metal part. The positively charged part in acid reacts with the positively charged part in base reacts with the negatively charged part in acid, that means Na plus SO4 2 Na plus SO4 2 minus. These two are combined and what is formed? Na2SO4 sodium sulfate salt is formed. And H plus ions and OH minus ions are combined and water is formed. Like that the neutralization reaction takes place. Then how these bases reacts with non-metal oxides? What are non-metals? Carbon, sulfur, phosphorus, halogens, that means chlorine, fluorine, bromine, all these are examples for non-metals. If you observe the position of these elements, sulfur or phosphorus or halogens or carbon, where they are present, these are on the right side of the periodic table. Actually, which are present on the right side of the periodic table, that are electronegative in nature. Which are electronegative in nature, that means they have a tendency to gain electrons, that are non-metals. Okay, what are the examples of non-metals? Carbon, sulfur, phosphorus, halogens, these are non-metals. When these non-metals reacts with oxygen, what are formed? Non-metallic oxides are formed. For example, if wood is burnt, wood means what is its chemical composition? Carbon. It reacts with oxygen, carbon dioxide is formed. When sulfur reacts with oxygen, sulfur dioxide and sulfur trioxide are formed. In the same manner, when phosphorus reacts with oxygen, phosphorus pentoxide is formed. This carbon dioxide, sulfur trioxide, phosphorus pentoxide, all these are examples of non-metallic oxides. Okay, when a non-metallic oxide reacts with a base, or when a base reacts with a non-metallic oxide, what is happened? Again, salt and water are formed. Here, calcium hydroxide. We know calcium hydroxide is a base. It is familiar to us. What is used to whitewash the walls? That is calcium hydroxide, what we call as lime water. When it is applied to the walls, that means when it is washed to the walls, it is grey in color. After 2 to 3 days, it becomes as milky white color, white in color. How it is happen? That means this calcium hydroxide, which is washed to the walls, reacts with the atmospheric carbon dioxide, and a white layer is formed on the wall, that is calcium carbonate, what we call as marble chips or limestone. Okay, calcium carbonate. That means this marble chips, chalk, limestone, all these are the different forms of calcium carbonate. It is a salt, calcium carbonate is formed, and water is formed, that is evaporated. That's why it gets dried. Okay, this is observed. It is also observed as the test for carbon dioxide. How? When carbon dioxide gas is passed through live water, it changes into milky white. Same this reaction takes place in this. Okay, that means this calcium hydroxide is a base, carbon dioxide is non-metal oxide. When this calcium hydroxide reacts with non-metal oxide, that is carbon dioxide, again salt and water are formed. That means it is similar to which reaction? Neutralization reaction. Generally, when this neutralization reaction takes place, when a base reacts with acid. But here, are we take the acid? No, what is taken? In the case of acid, non-metallic oxide is taken. That's why this non-metallic oxide is acidic in nature. Not only this carbon dioxide, all the non-metallic oxides are acidic in nature. All the metal oxides are basic in nature, and all the non-metal oxides are acidic in nature. Okay, these are the main chemical properties of bases. Okay, then these bases, what are the uses of these bases? These bases are used in our daily life also. For example, for washing clothes, what we use? Sodium carbonate. And in baking soda, okay, that means cooking soda, what we used? Sodium bicarbonate. Okay, all these are used in our daily life. Like that, these bases are also used. And sodium hydroxide, what we call as a caustic soda, its chemical formula is NaOH. It is also used. It is used in the preparation of soaps, in paper industry, and in to produce artificial fibers. Okay, this sodium hydroxide is used, and not only that, this calcium hydroxide is used, and this sodium hydroxide is also used to prepare bleaching powder. The chemical name of bleaching powder is calcium oxychloride. Like that, these bases are also used in our daily life. Okay, remaining topics we will learn in next class. Thank you.